Right. Good morning. Let's begin our session. So in the previous session, we were discussing about load balancer. So we have understood what is a load balancer, and we have seen the practicals of load balancer. Hope you can hear me. Is it good? Can you hear me? Venkat or Shaila, can you hear me?
Yes.
Oh,
Yes, I can hear you.
okay. So we had a discussion on the load balancer earlier, right? So we understood what is load balancer, all those things. So let's understand what are the different types of load balancers we have. Usually, as I told you, when we come to the concept of load balancer, we have different types of load balancers. We have an application load balancer. We have an application load balancer, which is suitable for HTTP or HTTPS traffic. See, application load balancer is suitable for HTTP or HTTPS traffic. It is a layer 7. Okay, usually we will call it as the layer 7, the layer that is used, usually the application layer. Now we can call it as layer 7. Okay, application layer is nothing but the layer 7. Actually, application load balancer operates at application layer 7. Usually there is a model called OSI model or ISO model, open system interconnection, or there is a model called OSI model. Okay, so this particular talks about the layers in the network. Okay, the layers in the network. So usually there is a layer called layer 7. Layer 7 is called application layer. So for now, what we need to understand is there are different types of load balancer. One is application load balancer. Application load balancer is a layer 7. Application load balancer operates at layer 7. Application load balancer operates at layer 7, and it is best for HTTP or HTTPS traffic. There is another load balancer. We have another load balancer, which is called network load balancer. There is another load balancer called network load balancer. This is suitable for high performance. It is suitable for high performance applications. And the network layer of the network load balancer is the network layer is here, it operates at the network layer, and it is layer 4. Remember, application layer operates at layer 7. Network load balancer operates at network layer, which is called layer 4. Okay, if you look at the OSI model, there is an OSI model. Usually, this OSI model talks about 7 layers. OSI or ISO model talks about 7 layers. You can see here, these are the layers. Can you see here? There are 7 layers in the OSI model. Each layer has its specific role in handling the data. Each layer has its specific role in handling the data. We have physical layer, data link layer, network layer, transport layer, session layer. This is how the network data transmission takes place. So we talk about, just now we spoke about the application load balancer. Application load balancer operates at layer 4. The network load balancer operates at application load balancer operates at layer 7, which is called application layer. Application layer is layer 7. Okay. We want to know what is layer 7. Layer 7 is application layer. Application layer. Layer 7 is application layer. Layer 4. What is layer 4? We have layer 4 called network. We have usually there is a layer called network layer. So network load balancer operates at layer 4. Remember, network load balancer operates at layer 4, which is called network layer. Okay. So try to understand why I'm explaining all these things is like we are going to we have different types of load balancer. We have different types of load balancer. One is application load balancer. Okay. Usually they'll ask you the questions in the interviews like application load balancer operates at which layer? Application load balancer operates at application layer, which is layer 7. Network load balancer operates at layer 4. The layer is called network layer. And this is suitable for web applications, microservices. Application load balancer is suitable for handling HTTP or HTTPS traffic, web applications, and microservices. When we come to the network load balancer, it is suitable for high performance applications. It is suitable for high performance applications. And you know the best example, you see, I'll give you one example to understand. I'll give you a small example to understand what is the use of network load balancer. Consider we have a gaming application. Usually, the gaming application might use network load balancer to distribute the traffic to the game servers. Why? Because it needs some performance. It needs some higher performance. Network load balancer, okay, the good example to understand network load balancer is usually network load balancer. The network load balancer is used in the applications of high performance. Wherever we require some high performance and low latency, there we use network load balancer. And we also have a classic load balancer, which we have already seen. This is suitable for our legacy applications or old applications. Simple load balancing, okay? Wherever you require simple load balancing, if there is a website and there you require some simple load balancing. In that cases, in that scenarios, we'll go for classic load balancer. Try to understand. Classic load balancer is suitable for legacy. Classic load balancer is suitable for legacy applications as well as simple load balancing needs. Okay. We also have another load balancer called gateway load balancer. Particularly, this load balancer is mainly to handle, can you see here? The network gateway load balancer is mainly for security. All the incoming traffic through a security appliances. Okay. So if you want to handle an application, if you want to handle the incoming traffic through a security appliance, then there we use this one, gateway load balancer. Okay. So slowly you will understand, but for now, what you have to understand is you need to remember a few things. We have different types of load balancer. Usually in the interviews, they'll ask you, we understood what is the main functionality of load balancer. The main functionality of the load balancer is mainly for handling the load. Okay, it will accept the incoming load and it will divert the traffic to the target machines, EC2 targets. That is the main functionality of the load balancer. In that we have several types of load balancer. Suppose if you want a simple load balancer, you can go for classic. If you have a simple web application, you can go for classic. And otherwise, if you have microservices approach, if you have microservices approach or if you have any kind of web applications, then you can also use application load balancer. Application load balancer is better for handling HTTP or HTTPS traffic. And if you have a high performance application like gaming applications and all, usually we'll go for network load balancer. Okay, if there is a high performance application like gaming application, we'll go for network load balancer. And there is one more called gateway load balancer. This gateway load balancer is for applying the security. Okay, if your application requires more security, then usually we go for gateway load balancer. Okay, so it is ideal for use with network appliances like firewalls, VPNs, all these things. Okay, if your application requires more security, then we'll go for gateway load balancer. And we will also we are going to understand, okay, anyhow, we understood what is the basic objective of load balancer. Now, for now, we need to understand one more important concept called auto scaling. after load balancing, we need to understand what is auto scaling. So anyhow, we understood what is load balancing. Let me take one more. You understood what is load balancing. Okay, consider we have a server, we have a web server, or otherwise we have some two web servers. Usually we have integrated a load balancer to the web servers. And I told you that whatever the incoming traffic coming from the outside, from the users, the traffic will be accepted by the incoming traffic. Okay, whatever the traffic coming from the outside, the traffic will be accepted by the load balancer. Load balancer will then divert the traffic to the servers. Load balancer will divert the traffic to the EC2 machines. These are the EC2 machines. These two are the EC2 machines. Consider there is a scenario that this particular EC2 machine can handle only 100 requests. Okay, if it gets more than 100 requests, okay, this particular server can handle only 100 requests. This particular server cannot handle more than 100 requests. And we have one more server. This particular server also handle only. Why? Because both are similar kind of machines. We used to take similar kind of machines only. This particular server, okay, server 2 will also handle only 100 requests only. It cannot handle more than 100 requests. So in this scenario, if the incoming traffic is more, if the incoming traffic is more than 200 requests, if the incoming traffic is more than 200 requests, what should we do? Hope you are getting my question. We have two servers and we have attached both the servers to a load balancer. Assume that we have a simple load balancer called Classic, which is used for our legacy applications, web application, where we do not require high performance and all. We are using a very simple load balancer called Classic load balancer. We have attached the Classic load balancer, and Classic load balancer is handling the load. It is accepting the traffic, diverting the traffic to the servers. We have two servers here. One is server 1, the other one is server 2. But the load is great, the load is heavy, the load is more than the capacity of the server. Server 1 can handle 100 requests. Server 2 can handle 100 requests. But the incoming load is more than 200 requests. What should we do? Usually what should we do is, we need to increase one more server. In this particular scenario, we need to increase one more server. Okay, if we are getting a load of more than 200 requests, we need to increase one more server, which is called server 3. And then if this server will also handle some 100 requests, then that is fine. Okay, it can able to handle the load, which is getting more than 200 requests. But consider the scenario, okay, consider the scenario where we cannot expect the traffic, where we cannot guess how much load will come. And you can consider our simple applications. Okay, you can consider, one second. Where you can consider, yes, okay. So assume that we are talking about a concept of auto scaling. So usually what is auto scaling here? We have server 1, server 2, and we have server 3. So when we have integrated 3 servers to the load balancer, what is happening? Whatever the requests we are getting from here, all the requests are being diverted to these servers, server 1, server 2, and server 3. Okay. And consider the scenario where it is going to handle, okay, where the incoming traffic is more than 300 requests. Suppose if we are going to get the incoming traffic as more than 300 requests, what should we do now? Okay, we could not able to guess. You can take some applications, okay? You can take some example applications like Amazon, Flipkart, Okay. So during the offer times, during the big billion days, okay, some Amazon offer times. So usually they get high load than usual. Usually they will be getting higher load than usual. Then how actually the traffic can be maintained? How the actually the traffic can be balanced? How we are going to handle that? Anyone can tell me like how they are going to handle the traffic? So usually the traffic can be handled by implementing a concept called by implementing a technology called auto scaling. So what happens is here we enable an auto scaling mechanism so that what happens? Suppose all of a sudden, if we are going to get all of a sudden, okay, I'm talking all of a sudden, if we are going to get some 500 requests, we don't need to add servers manually. Okay. So we don't need to add the servers manually. By default, it can add the servers automatically. If we implement or if we enable auto scaling concept, then it will automatically add the servers. It will automatically add a similar kind of servers. And then the load balancer will divert the traffic to those servers. Suppose if it is the hand if the each and every server is handling only 100 requests. If each and every server here will handle only 100 requests, then based on that, it will keep on increases the instances. It will keep on going for increasing the instances. Okay. So if 300 requests, if it is getting 300 requests, only three servers are enough. If we are going to get some 400 requests, four servers are enough. If we are going to get some 500 requests, five servers are required. So based on that, it will automatically increase the number of servers. And whenever the load decreases, we cannot say, right, every time the load will be there, the same load will be there. The load will be decreases. When the load will be decreases, whenever the traffic, okay, whenever the number of users trying to access the application decreases, that is nothing but load, right? So when the load decreases, automatically the number of servers will also get decreases. Okay, so auto scaling is nothing but increasing the servers. You see here, auto scaling is nothing but what? Automatically increasing the instances or automatically decreasing the instances. In this particular example, you can understand auto scaling is nothing but automatically increasing the servers or automatically decreasing the servers. Whenever the load increases, whenever it get more requests, more number of users are trying to access the application, that time it can automatically increases the servers and the load balancer will divert the traffic to those servers. Whenever the load decreases, automatically the servers it detaches the servers. Okay, it will decrease the number of servers. So auto scaling is nothing but what? Automatically increasing the number of servers as well as automatically decreasing the number of servers to balance the load, to handle the load. Any questions in understanding the basic idea of auto scaling? Let's discuss. Any questions in understanding the basic idea of auto scaling? Why we need to enable auto scaling here? Why we need to enable auto scaling in the AWS? Hope you understood the concept of load balancing. If you are able to understand the load balancer concept, then you can easily understand why auto scaling is required. Auto scaling is mainly for handling the load, handling the unexpected loads. If there is an unexpected traffic, meaning more number of requests coming from outside, then how we are going to handle that? We cannot handle if we cannot handle that if we are not enabling auto scaling, it's very difficult to handle that. So always remember, if you want to handle the high load, unexpected load, definitely we need to enable auto scaling. Okay. So let me show you where we should go for enabling the auto scaling and all. We need to go to the EC2 dashboard. Okay. We need to go to the EC2 dashboard. Under EC2 dashboard on the left navigation, we understood, right? Load balancer. Okay. We have load balancer. At the same time, we also have auto scaling groups. Just click on auto scaling groups. You need to go for EC2 dashboard. Okay. We should go for EC2 dashboard. Or otherwise, you can also directly search here in the search bar. Under EC2 dashboard, you will find auto scaling. Okay, just click on auto scaling group. And here you can see like how to create an auto scaling group. Just click on create auto scaling group so that these are the steps we have. We need to choose the launch template, launch instance, launch options. What is this launch? The very first step you see, whenever I'm going to create an auto scaling group, first thing is it is asking to provide some auto scaling group name. It is asking to provide the auto scaling group name. Then immediately the next step is it is asking for launch options. Okay, it is choosing for launch options. It is choosing the instance launch options. What do you mean by launch template? Let's understand what is launch template. Okay, so we understood the meaning of automatic auto scaling, right? Auto scaling means what? Automatically increasing the instances or automatically decreasing the instances. Okay, so if you are enabling the auto scaling, we should give the launch template. Okay, if it has to launch a server, what I told you, what is auto scaling? Automatically increasing the server, automatically adding one server. If it has to add one server automatically, okay, we need to give the launch, we need to specify the launch template. Otherwise, how can it add the server without specifying the launch template? We should give a clear picture like you should launch one server with t2.medium, okay, with t2.medium configuration. Try to understand. We should specify the launch template like please launch the server, okay, whenever the load increases. Whenever the load increases, please launch the server with the t2.medium configuration and with the 2 CPUs or 4 CPUs. Okay, however, so whatever the launch configuration you would like to provide, you need to mention all these things. If you want any storage, yes, I require some 32 GB storage. All these things you need to provide. All the inputs you should provide. This is called a launch template. Otherwise, it doesn't know what kind of server it has to create. It has to add. So that's the reason why whenever you enable auto scaling, the very first step is it is asking, give me the launch template. What kind of server I should launch? Whenever the load increases, what kind of server I should add to your group? So these are the things that it is asking. So that's the reason why you can understand here. Okay. You have a launch template. First, you need to provide the launch template. And then you see once the launch template is provided, the next, okay, you can see here, we are not moving. We are not going for the further steps. Why? Because until you provide the launch template, you have to provide the launch template. We have some other options here. After choosing the launch template, we have some other options like step 2. Okay, choose the launch options. So let me give you the let me provide the auto scaling name. I'm going to provide the auto scaling name as my auto scaling. I'm providing the name of the auto scaling as my auto scaling. And then it is asking the launch template. What kind of launch template I should provide? So here we have an option here, how to create a launch template. Click on it, open a new tab and see how can we create a launch template here. Okay, you understood, right? I'm just clicking on it to create a launch template. And you can see here, what are the things that it is asking. I'm just providing the name as my launch template 1. Okay, it is asking the description. This is to test. Okay, I'm just giving the mechanism. This is for testing. This is to test. You can provide anything. Okay, description, template version description. This is to test. I am giving the description as this is to test. Launch template name as my launch template. Going down, it is asking to choose the OS images, all these things. You can choose the OS images by just clicking on browse more AMIs. I'm selecting Amazon Linux. You can select any of the AMI. I'm selecting Amazon Linux AMI. Coming down, instance type it is asking. I'm going for T2.medium. T2.medium is the machine type I require. Okay, Amazon Linux operating system. T2.medium is the instance type I'm selecting here. So how many CPUs I get here? Suppose if I choose T2.medium, I'm going to get 2 CPUs as well as 4 GB memory and 2 CPUs. And if you want to add key pair also, yes, you can add. If you don't want to include, ignore it. Okay, for now, we don't need the key pair. Why? Because we are not going to connect to those servers. If you want to connect to those servers, yes, definitely you need to provide the key pair. For now, I'm just mentioning like don't include subnet and all. Like I am not going to provide any network settings. By default, it will take some default settings. Okay, by default, it will take some default settings. And we need to provide the existing security group. If you want to create a new security group, yes. Or if you want to go for existing security group, it's okay. Okay. So security groups, it will ask you. So usually we go for security group called Launch Wizard 21. You might have already understood. Earlier, we have created a security group. And what are the things that I have enabled here under this security group? I will show you. Okay, we have enabled SSH port as well as HTTP port, all traffic, I think. Okay, we are going for Launch Wizard 21. This is a security group I'm choosing. It is not mandatory that you have to go for this particular security group. You can create a new one also. That's fine. Okay. I'm going for the next one. I don't want any storage volumes for now. I'm not going to add any storage volumes for now. I'm having Amazon Linux AMI, T2.medium, Amazon Linux AMI, T2.medium, and then I'm going to choose here. This is the security group I'm choosing. By default, we are going to get some 8 GB hard disk. I'm going to launch the template. Okay. So, now you understood now I have created a my launch template one. I'm coming back. I'm going back to the EC2. Sorry. I'm going for my auto scaling group. I came back. First, you need to select auto scaling. What you need to provide here, the name as my auto scaling group. I'm just providing the name as my auto scaling group. And the launch template, if you refresh here, you can see my launch template one. This is the one I have created. Just now I created this one, my launch template one. Going down, I'm going for the next. So launch template is done. So the next thing it is asking is, okay, launch options, instance launch options. Okay, for now here, you can see it is asking to choose the availability zones. Okay, it is asking to choose the availability zones. I'm choosing the first 2 availability zones. Okay, so I would like to launch the servers in the first 2 availability zones, US East 1A as well as US East 1A. So it is asking, so you want to launch an instance, okay, under this VPC. Under which availability zone you would like to launch? It is asking. I am just providing these options. So it can launch the server on this availability zone, US East 1A. It can also launch the server on this availability zone, which is called US East 1B. Going down, here we have 2 options, balanced effort, balanced only. Okay, you can see here, what is this balanced best effort? We have 2 things here. If launches fail in one availability zone, auto scaling will attempt to launch in another healthy availability zone. Suppose we have selected 2 availability zones here, US East 1A and US East 1B. So it will try to launch in one availability zone first. If it is failing to launch in one availability zone, It will try to attempt to launch in the another healthy availability zone. What is balanced only? If launches fail in one availability zone, auto scaling will continue to attempt to launch in the unhealthy availability zone to preserve the balanced distribution. You understood, right? So suppose if it is trying to launch a server in US East 1A, if it is not working, it will go for US East 1B and then it will launch when we select this particular option, balanced best effort. If it fails to launch in one availability zone, it will go for another availability zone and it will create. If I select this balanced only, when it is trying to launch a server in US East 1A, again it will try to, even if it fails also, it will retry to launch the server in the same availability zone only. Okay, it will retry in the same availability zone, it will retry. That is called balanced only. Better you can keep balanced best effort. We'll go for, so whenever we keep balanced best effort, but when we keep the balanced best effort, usually the we need to pay more. Why? Because it will try in the another region. Okay, if one region is failure, if there is any issue with one region availability zone, it will go for another availability zone. So you can select any one option here. I'm selecting balanced best effort. I'm going for the next. So here we need to attach the load balancer. So you understood, right? We have created one load balancer earlier, the classic load balancer. If you go to this option called attach to an existing load balancer, you can choose from classic load balancer. We have already a load balancer earlier, but I've deleted it. So for this, what I need to do is to see this one in real time, to see the auto scaling, to see the practicals of auto scaling in real time. We should have the auto scaling concept up and running. Got it right? I'm just showing you now. So in the next class, I will show you by configuring by the before itself. Okay, before we start our session itself, I will configure the load balancer and I will show you. But I'm just showing you. Like definitely to see the practicals of auto scaling group, you need to have the load balancer. Go for creating a classic load balancer. Take two servers, install a web package in it, HTTP web package, which I have given you, and make sure that load balancer is working fine. And attach the load balancer here. Okay, when you click on choose from classic load balancer, your load balancer will be listed out here. So select the load balancer and go for the next options. Once you select the load balancer, we have some other options like configuring the size, configure the group size and scaling. You have options here like configuring the group size and scaling. What is this group size? I'll tell you. I'll let you know what is this group scaling and all. Usually, you need to provide the minimum number of instances and maximum number of instances. For example, okay. So usually, after attaching the load balancer, we need to provide these two things. The next step. What are these two things? Minimum number of instances we need to provide. At the same time, we should also provide the maximum number of instances. If the minimum number of instances is 2 and maximum number of instances are 10, always 2 instances will be up and running. Okay, if you are enabling auto scaling and during whenever you enable, okay, or when you enable auto scaling, so it will ask you the basic configuration in this particular step. Just now I shown you. Okay, this is like group configure size and scaling. In this particular step, it will ask you how many number of instances you want to, how many minimum number of instances you want to maintain forever. Even though if there is a high load or small load, if there is no load also, even the minimum number of instances you want to maintain. So for that, we can give the minimum number of instances as even one also. If you provide one, always one instance will be there up and running, providing services to your users. Okay. And if the maximum number, if the maximum number of instances as 10, even though the traffic increases. Okay. I told you like 100 requests, one server can handle one server can handle 100 requests. This is an example we have taken. I told you one server can handle 100 requests. Suppose if we get some 1,000 requests, how many servers we require? If we get some 1,000 requests, how many servers we require? All right, 10 servers we require. Why? Because one server can handle only 100 requests. To handle 1,000 users, we need some 10 servers. I'm just taking an example. Suppose if we get more than 1,000 requests, okay, more than 1,000 requests, even though you enable auto scaling, okay, even after enabling auto scaling, you mentioned that the maximum number of instances are 10. It won't go beyond the 10. It won't go beyond the 10. So how auto scaling works? If you specify the minimum number of instances as one will be there always. Okay. And the traffic increases. When the traffic increases, when the load increases, what happens? It will add one more instance, to it. Again, if traffic increases, okay, again, if traffic increases, it will add one more instance. So now, for now, we have 3 instances. So whenever the traffic increases, it will keep on increasing the instances until a maximum number of instances until the maximum number of instances called 10. If it reaches to 10, it won't add any another instance. Why? Because in the configuration itself, we are mentioning the maximum number of instances we require is 10. Maximum number of instances we are restricting as 10. Even though the load increases, it won't add any instance beyond 10. It won't add any instance beyond 10. Okay. So, and you can see here, one thing we should understand very clearly. This is the one, this is config, this is the main configuration. Minimum number of instances and maximum number of instances we are giving. So, how actually this auto scaling knows, okay, we are talking about auto scaling. We know, we are understanding like, if we enable auto scaling, automatically the number of instances gets added, the load can be balanced, the traffic can be balanced like that. How actually it will increase the number of instances? So we actually need the parameters, okay? We need to provide some other parameters also. The main parameters that we need to provide is CPU utilization and memory utilization. Most of the times we use CPU utilization only. Okay, we can also use memory utilization also. Let me give you an example. How it knows it has to add one more instance. How it knows the traffic has been increased. You see here, if one server is getting some 100 requests, the CPU utilization of that particular server will definitely increases. If it is handling only one request, if a server is handling only one request, the CPU utilization will be very less. If it is handling 2 requests, the CPU utilization or CPU consumption will be little more. If it is handling 10 requests, 10 users are trying to access, if 10 users are trying to access the responses from the single server, usually the CPU utilization will be definitely more. And the same way, if 100 requests, if 100 users are trying to take the responses, trying to get the responses from single server, definitely the CPU utilization and memory utilization will goes high. So there we are keeping one restriction. Okay, we need to write some expressions. Okay, we are going to do some parameters. If CPU utilization will go beyond 80%, there is a condition. Okay, we are going to add some conditions for auto scaling. When it adds one more instance, if the CPU utilization of the instance one, for now we have only one instance, and this instance got 100 requests, or otherwise some 90 requests. The CPU, we should not wait until it get the 100 requests. Make sure. If the capacity of the server 1 is 100 requests, we should not wait until all the 100 requests come to this. Okay, that's where we are writing a condition. If the CPU utilization of this particular instance is greater than 80, then it will add one more instance. Okay, we are going to write some metrics like if the CPU utilization is greater than 80, then add instance. Okay, this is the condition. If CPU utilization is greater than 80% of the CPU utilization of instance 1 is 80%, then add one instance. So that instance will be added. Try to understand, instance will be added, and this instance will also handle the traffic. This instance will get ready to handle the traffic. Again, if the load increases, okay, the condition we are going to write, instances, if both instances average CPU utilization, if both instances average CPU utilization is greater than 80%, I'm talking about both. Here we had only one instance earlier, but now here I'm talking about two instances. If both instances average CPU utilization is greater than 80%, then add one more instance. This is how actually things go. You understood, right? If I had only one instance, okay, we will monitor. Actually, we are going to monitor the CPU utilization. Not we. Actually, we are having some other services where it monitors the CPU utilization. If the CPU utilization of the server 1 goes 80% or touches 80%, immediately it will add one more instance. This instance will take the load. This instance will share the load. Again, now we have two instances so far. One more instance is added. Now we have two instances still here. And if still the load is increasing, okay, we are writing one more condition. If both instances average CPU utilization is greater than 80, average CPU utilization is greater than 80, then what is average CPU utilization? If the CPU utilization of server 1 is only 70, if CPU utilization of server 2 is 80, 70 plus 80, 150. 150 by 2, 75 only. Okay, so average means we need to take both the server's CPU utilization, we'll calculate, and if it is touching 80 again, then it will add one more instance. Got it? So this is how actually we are going to add the instances. Any questions still here? Do you have any questions in understanding this, how we are going to? So any questions do you have in understanding this basic idea of auto scaling?
Hello.
Yes, yes.
Yeah, can you show adding all these in console
Yeah,
in
sure. I'll
practical?
show you.
Yeah.
I'll show you. It will take some time. Why? Because we need to launch. So we have all these options. We should do all these things. Okay. I'll show you in the next
Okay.
second. We should configure. We should add some notifications, and we should also go for some load balancer. You see, whenever we are going for launch template, and it is asking. You see, whenever we go for advanced options, it is asking to attach
Okay.
load balancer. Okay. So make sure why I'm showing all these things is make sure to practice this auto scaling, you should have load balancer up and running. Make sure the load balancer is up and running so that you can attach the load balancer here. And based on the launch template you have provided, it will keep on add the instances. And where I told you like we are going to give the minimum number of instances and maximum number of instances, right? Where we are going to provide that here in the configure group size and scaling, we are going to have minimum number of instances and maximum number of instances. Okay. So if you want, yeah. So the basic requirement here is like we need to attach a load balancer. We need to start a load balancer. Okay. We need to configure the load balancer again. And that load balancer can be used here. And we will also come up with some new services. Okay. We will also come up with some new services So let me, for example, okay. Anyhow, we are not going to see the output today. We are not going to see the output today, but let me show you what are all the prerequisites that we require. I'm going to add one load balancer. Simply adding a load balancer. Okay. I'm simply creating a load balancer. I'm going to the load balancer feature. So where the load balancer feature is here under the EC2 dashboard only. We have in EC2 dashboard. Under EC2 dashboard only, we have the load balancer. Please go to the load balancer. Otherwise, you can select here the load balancer. Create one load balancer. I'm going with classic load balancer. This is a simple load balancer for configuration. So I'm going for this one, my load balancer. I'm giving the name of the load balancer as my load balancer. Okay, internet facing only. Availability zones. I'm selecting these two things. I'm going to add the security groups. Make sure that I'm using the security group called launch wizard 21 only. Okay. You know why I'm using the security group. We have enabled SSH, all the traffic, all these things under this launch wizard. So I'm going down and we understood the importance of advanced health settings and all. We understood why we configure all these advanced health check settings, all these things. I'm just going ahead and creating a load balancer. Nothing I'm doing, okay? I'm not adding any instances also. Actually, we need to add the instances. But for now, I just created a load balancer to see what are all the other requirements we have. So after creating the load balancer, I'm going for auto scaling groups, create an auto scaling. I'm just going for my auto scaling group, okay, my auto scaling group. Launch template, anyhow, I'm selecting my launch template one. I told you already how to create a my launch template. So if you want to create a new launch template, here we have an option, create a new launch template. Just click here and you can create your own launch template. Going down, I'm going for the next option. And here we are choosing only two availability zones, okay, US East 1A and US East 1B. Going for the next, attach an existing load balancer. Attach the existing load balancer. We have a classic load balancer. That's why I'm choosing this option. We have any other load balancer, we need to go for this one. Choose your load balancer from the target groups. So I have a classic load balancer. I'm going for here. Choose this, choose your load balancer. Come down. And you don't need to go for this VPC settings. Why? Because we have not enabled any, okay, VPC, all these things for now. For now, what I'm doing is I'm just adding an existing load balancer. That's it. I'm going for the next group size. Can you see here? This is the important thing. Group size and scaling. So desired capacity. For now, you need only one server. Forever, you need only one server. Okay. And minimum desired capacity should be only one. And whenever the load increases, you need 4. Okay. It won't go beyond 4. If you're keeping the maximum number as 4, it won't go beyond 4. If the minimum number of servers you keep as 2, it will launch 2 servers. It will launch 2 servers in the beginning, and the 2 servers will be always there, even though you have the load or not. But always make sure you need to keep the minimum number as 1. Okay, we can keep 2 also. What happens if we keep 2? So we need to pay more bill. If I keep 2, so even though if there is a necessity, if necessity is there or not, 2 servers will be always up and running. So that's the reason why I made the minimum capacity as 1, maximum capacity as 4. Okay. And here, okay, here you see, we need to go for the next one as automatic scaling. Okay. Can you see? I'm selecting, I usually, you can go for no scaling policies. Okay. So usually whenever you go for auto scaling, you should go for target tracking, target tracking. If this target tracking is not there, there is no use actually. Okay. There is no use for enabling the auto scaling also. So I'm going for target tracking scaling. So you need to select the metric here. What is your metric? Suppose if the average CPU utilization goes beyond 80%. Okay. If the average CPU utilization goes 80%, then it will add one more server. Okay. So if the average CPU utilization, there are many other things. Okay. If you can go for memory utilization also, maybe here it is not displaying. Okay. So usually to track, okay, to go for this tracking scaling process policy, we need to go for a service called CloudWatch. Okay. We need to go for a CloudWatch. Simply, you can go for CloudWatch, target tracking policy as CloudWatch. So here we need to configure a CloudWatch policy. I'll show you what is CloudWatch and all, what we are going to do with the help of CloudWatch. So for enabling auto scaling, we should also learn about another service called CloudWatch. Okay, I will tell you the purpose of learning. What is the purpose of learning CloudWatch? Please go for selecting the CloudWatch and you can easily understand. CloudWatch is a monitoring tool. CloudWatch is nothing but a monitoring service. So who monitors whether the CPU utilization is 80% or CPU utilization is 70%? Who will monitor? So for that purpose, we need some monitoring service. As I told you in the example, if the CPU utilization is greater than 80%, it will add one more instance. Or otherwise, again, immediately after the load, if the CPU utilization is reduced to 20, or the CPU utilization is reduced to 30, again, it has to remove the instance. So who will monitor all these things? We have a service called CloudWatch. We have a service called CloudWatch. In the CloudWatch, we can go for alarms in alarm. Okay. This CloudWatch will continuously monitor your services. And whenever it reaches the parameter, it will trigger the alarm. Okay. So in the CloudWatch, actually, we are going to create some alarm. Select the metric. What it is asking, then go for the service. Okay. We need to select the service. It is EC2. We need to select EC2. We need to select EC2 and we should select some metric here. Okay. We will understand in the next session how we are going to create an alarms in the CloudWatch. What is CloudWatch service in detail? Okay. This is the CloudWatch service. If you want, you can go through this service once. There is a service called CloudWatch. What is the purpose of this CloudWatch service? CloudWatch is mainly for monitoring. So for enabling auto scaling, we should know about some other services. Okay. For example, CloudWatch. CloudWatch is a monitoring service. In CloudWatch, usually we will set some alarms based on some parameters. If the CPU utilization reaches to 80%, it will trigger the alarm. So that's how we can manage this auto scaling. So in the next sessions, we'll see the practicals of these things. Okay, how we are going to use CloudWatch as a monitoring service, and how actually the CPU utilization, whenever the CPU utilization increases or memory utilization increases, how it is going to add the servers, and how it is going to decrease the server, and all these things we will be discussing in the session. Any questions you have?
Hello? Hello?
Yes, please.
Yeah, like if the CPU utilization goes by below 80, it will automatically delete the next server.
Yes, whatever the server it has added, right? So it is
Okay.
going to delete that server. But minimum will be always there. So we are providing minimum and maximum configuration, right? Minimum size and maximum size. So if you keep minimum as 2, those 2 servers will be always there.
Okay.
The newly added server will be removed from there if the CPU
Okay.
utilization is reduced.
Okay.
Okay then. Thank you. If you don't have any questions, we'll continue tomorrow.
Thank you.